So we were going to look at automatic tally transformation, but there's not much point in doing that. When you do tally transformation, you want to make sure that everything is done properly, so the best way to do that is just to do it manually. So that's what we're going to look at. So if we open our VMR that we created, we have it here. So this is as an anatomical space. We can click on Full Dialog and go into the tally tab. So we want to go from anatomical to ACPC. So we want to do this manually. And the first thing it wants us to do is to find the AC point. So the easiest way to find the AC point is if you follow the corpus callosum, right here you have this little deviation away from it, and right at the bottom is the anterior commissure, that's our AC point. So we click on that, and then looking at our transverse view, you can see that AC point here transverses both hemispheres, and if you scroll up and down through the brain, it disappears. So what we want to do is we want to find the point where it is most clear, and I would say that's about a good point for AC point. We also want to make sure that we bisect both hemispheres equally, so we can move left and right through the brain to make sure we've got that done. That looks good, especially on the chrono view. So we'll choose that. And then the second thing it wants us to do is to find our ACPC plane. So this is just a rotational exercise. We have our AC point, and just in the x-axis we want to rotate the head so that the posterior commissure comes into view. So if you look at the transverse view on the right here, you can see if I scroll up, the PC point comes into view, and then eventually it disconnects. So if we scroll down again, there it's connected. If we look at our sagittal view, you can see that we're cutting through the posterior commissure, so that's not a bad point. But we also want to rotate the head so that we're bisecting both hemispheres equally. So in the y-axis, we can just rotate the head until it looks like we're splitting both hemispheres equally. So that's not too bad. And for our transverse view, we can rotate in the z-axis and just wind up so it looks like everything's equal. That's not too bad there. So we'll accept that as our ACPC plane, and we'll transform to ACPC space. We'll create a new file with this underscore ACPC attached to it. This will take a few seconds. We can close our old VMR. So now we're in ACPC space. We want to get into TowerX space. So to do that, we need to define a number of points around the brain. So we have our AC point, that's fine. We can check our PC point. So in our transverse view, you can see that our point is just a bit more anterior than where we'd like it to be. So if we hold down Shift and press the down key, we can just move backwards to the brain until we're on the PC point. That's fine. We can set that. We can then look at our AP point. So looking at our coronal view, we want to move backwards to the brain until we start to see cortex appear. So there's some cortex. If you move forward, we're just looking for the point where it just disappears. So that's probably about where our AP point would be. Now we want to look at our PP point again. So we've got some cortex here. We want to just scroll backwards until the cortex disappears. There it goes. So this would be our PP point. But because our lab studies visual processing, we want to make sure that we always get the visual cortex in our TowerX space. So what we do is we find our PP point and then just come back another 2 points. And we can set that. Our SP point, we're looking at our transverse view. So if we move down to the brain, there's cortex, move back up, it's disappearing, it's gone probably about there. So that would be our SP point. the IP point, this one's quite difficult because you're looking where the temporal lobes disappear in this transverse plane. So if we scroll up, we can see cortex on either side here, behind the eyes. If we move down, you can see it just start to disappear. There's some there. Not sure what that is. Probably gone, so we can define that as our IP point if we're confident that this is cortex. RP point, this is the left and right exercise, so there's cortex there, and there's agile view. We can move left, and there it goes. So that would be our RP point. Our LP point, same again, cortex, moving away from the brain. There it goes. So that would be our LP point. And now that we've set all our points, we can save our TAL file. So we'll just save over the one we already have. And we can convert from ACPC space into TALREAC space. And again, we'll create a new file with this extension TAL. And that's us. We can close our ACPC VMR. And that's us converted from anatomical space into TALREAC space. This concludes this tutorial. The next one we will look at how to create a VTC file.